Hey guys, welcome back to AlgoYogi. We are now doing stack series, and our next problem in the list is implement stack using queues. I think this is a basic implementation question, which is just asking us to use queues using a stack. The stacks could be implemented using like arrays or list or any other data structure. I think stack is a really simple data structure that has all these push, pop. Top is usually peak when you're peaking the topmost element, and empty is like if your stack is currently empty. So this is a Boolean return. So okay, let's read it out. Implement a last in first out. So stack is a LIFO data structure. LIFO is last in first out. Whatever goes in the last, that comes out the first. Using only two queues. You don't have to use two queues. We can use even one queue, but to make the most optimal solution, you can use two queues. The implemented stack should support all the functions of a normal stack, which is push, which is top, pop, empty. Those are the regular functions of a stack. You can add more functions, but basically getting the first value what is on the the bottom of the stack, but that's not the a general regular function. So we're going to implement all of these functions. First thing is push, then pop, top, and empty. So let's understand how we're going to do it using a queue. So in Python we have queues, basically this data structure that is called DQ. I think it's implemented using DEQUE. I think that, yeah. So let me just correct myself. DQUE. So this is the data structure that is in Python. That was a weird way of writing Python. Okay, so Q is a FIFO data structure. FIFO, that means first in first out, right? And stack is a LIFO data structure. Now we need to implement stack using queue. So let's understand fundamentally how stack would be different than a queue. It's going to be just this one particular case, which is, let's say you have a queue. We have a queue. I'm just going to write queue here. So queue, we have a queue, and then let's say we have some values. Okay, initially let's say we don't have any values, we just have empty queue like this, and then we have a stack like this. Then now, because this is a FIFO data structure and stack is a LIFO data structure, so if I'm pushing something, which is if I'm appending something to my queue or pushing something in my queue, that means both operations in my stack and queue is going to be same. So I'm just trying to show this similarity between and difference between queue and stack, so that we can actually implement stack using queue operations. And for that we will be using DEQUE. This is what we will be using. Okay, this is what we will be using, DQ. That's an implemented Python data structure that represents a queue. So if I'm pushing something, so that means in my queue and stack both look same. How about if I push another thing? So I'm gonna push, let's say 2 to my queue and to my stack. Now if I'm popping out something, so if I'm popping out, this stack will return 2 because that is on the top of the stack. So this could also be represented as stack like a regular stack, which is pushing 1 and then pushing 2. And now if I have to basically peek in or top, this is the top top is right here on the top. This is top in my stack, and if I'm basically popping out something, this is what comes out. So popping from a stack will give me the last value, which is 2. But if I'm popping something out from my queue, I will be getting this value, which is usually pop left. Left means this side, whatever is in the front, because this is a FIFO data structure, and that's those properties are basically entangled with this definition of queue. So popping something out means I'm getting 1 and not 2, but I want 2, right? I want 2. So what I want to do is, whenever I'm implementing a stack using a queue, there's just simple thing that I want to do, which is basically I will, whatever I pop out, so whatever I pop left, that is the function name, pop left. Whatever I pop left until one element lesser than whatever the length is going to be of this queue, push them back here, so that whenever I pop this out, I will push them back here until the last element. Don't touch the last element, just everything before that, and then pop that out and give it to the user, right? I think you understand what I said here. It's a simple thing. Let's understand all the operations that we will be doing now. So I think now we understand how queue is different than stack. So let's say there are few things using this. I'm going to write out the functions that we will be implementing. First is going to be push. Push is simply simple push, basically append to the DQ. So DQUE, this is what I will be using, right? And I just want to simply append it to my DQ. Then I have pop. Pop will be basically push everything to the end except last. Push everything to the end of my queue, of my DQ, except the last element that is there in my DQ, and then return the basically that last element. So I think I've shown you, and then we have top. Top will be basically DQ -1, which is like the last element that I just pushed, and then there is empty. Empty is going to be basically if length equals to 0, right? That means it will be empty. So I think now we understand, and once we implement it, it's going to look really simple. So I'm gonna switch the view here, and then we can start it. It's a simple problem, honestly. So one thing is I want to switch the view and charge my laptop. Okay, looks pretty good now. So first thing first, we're going to use a DQ. So I'll say self.dq, or I'm just gonna call it q. Q will be having dq. That will be my, should I have it new? Is that how? No, I think you just have it simple dq created. I think that's it. Self.dq is going to be q. Then if I want to push to my q, is going to be self.q dot I think in dq we have this push operation, but I'm just gonna call it append. I'm gonna call it append. All right. Or instead of dq, I was thinking if we could have just simple array also. But it doesn't matter. I think this. Let's do pop now. Pop will be, it doesn't return anything, so it's just appending the x that I just got. Then we have pop. Pop is about basically I'm going to run this loop for val in range for, I think I can call it I in range len self.q minus 1, so that I'm not touching the last element, but whatever I'm seeing before the last element, because I need to pop out the last element, I will push that back. So self.append q.append the last element will be we can access that by self.q with an I. Okay, so we can access that, and then or I think you could just pop left. I think that's the operation. Pop left from this particular index, okay, right from the beginning. Or I think we don't have to even say this pop left index. Pop left means it's popping right from the beginning. That's how a queue works. Whatever you have pushed so far, it's gonna get if you want to pop out some element, it's gonna give you the first element, whatever was pushed first. That's why it's called FIFO, first in first out. Now whatever we have pushed, there will be just one remaining element, because we were trying to just get the basically one less than the total length. So there is still one more element, and that's the one we are going to actually return. So we will say return self.q dot pop left. Okay, I think that's it. That's about pop. And then how about the top? I think we're going to return self.q -1, because that represents the top element, which is like the last element, but from the back, and -1 is basically -1 index from the back. That's how you access it, not -0. -0 is nothing. Okay, so I'm sure these are basics that I expect us to know. Okay, empty is if the length of self dot, so I'm gonna say len, ये तो win है या len है? Okay, yeah, win है या len है? self.q length of self.q is equals to 0. If that's true, return true, empty, otherwise false. So these two look good, and dq is what our data structure is. And we appended everything from the end. So I think this all looks good, and instead of this push, I could just call this function as well. So I am going to put this over here so that it looks like we are utilizing the functions that we have implemented. Okay, I'm gonna zoom out and let's try it out. I might be wrong about how we have assigned this queue here, but you know what, we'll check it out later. I've zoomed out. Yes, this is a little operation pop left, and I think now we should be good. What is it? Has no attribute as push. Collections.dq doesn't have any as push. I was not calling push, I was calling this particular function. But anyway, is it because we had to call it like this function as self dot pop left? Is it pop left? Okay, no, q dot pop left. Oh my god, did I make any other mistakes here? No. Okay, awesome, finally. Let's submit it. All right, 100%. Let's write the time complexity. I think these are all declaring, adding, checking the last elements, and checking if it is empty. These are all big of one time complexity operations. And so time complexity, and only I think this operation pop is what will be big of n, and that's because we are going over all the element except one last element to again keep popping them, unappending them from the end. So it's like if my queue was basically 1, 2, and I think I shouldn't call it queue, I should call them stack. If my queue looked like this, which was representing my stack, and I wanted to pop the last value, which is 4, so what I'm doing over here is I am going until here and taking value one by one, and I am appending them to after 4. So like this. So I must have appended 1, then 2, and then 3, and there is one value left which I just popped out from my remaining this value, because I only iterated one less than the length. So then I pop this out, pop 4 out, pop left 4, and then stack has 3, 1, 2, and 3. Okay, so this is what we wanted. We wanted to return 4, which is at the end of the queue, but we can't access that directly in a queue because queue is a FIFO data structure, first in first out. So we had to like pop everything out from the beginning except just last element, push them back, pop out that last element which is now in the front. So pop it out, return it. Everything good? Okay, so time complexity, except this thing, everything else is just big of 1 except this guy, which is big of n. Okay, so now we are all good, and I am going to go back to AlgoYogi and mark this problem solved, and see you guys later. Until then, bye bye. I hope everything was clear.